When Mike Sally left his job as head of a global team of robotics engineers at Uber in 2019, he had spent years helping the ride-hailing giant develop the computer vision systems used in autonomous cars. And as he set out to build the world's most advanced farming tools, he knew exactly what to do at his new company, Carbon Robotics, based in Vancouver, British Columbia. Sally and his team have developed an AI-powered weeder called the LaserWeeder that can identify and remove weeds from fields faster and more efficiently than a human farm worker. And the way it does it is by applying the same sort of machine learning techniques that have been used to teach self-driving cars to recognize pedestrians and cyclists. In fact, the systems are so similar that the training data used to teach LaserWeeder how to identify different types of weeds and crops is nearly identical to the sorts of images that self-driving cars use to learn their trade. It is a technique that could bring big changes to agriculture and other industries that rely on identifying objects in photographs. Today, many of the world's largest companies, including Amazon, Google, and Microsoft, offer cloud-based image recognition services that can identify hundreds of different object types, everything from dogs and bicycles to stop signs and railroad cars. But these services aren't necessarily designed to work in the resource-limited environments found on farms, ranches, and in fields. That's why many companies like John Deere are taking a different approach. They're rebuilding computer vision systems that rely on machine learning algorithms, running locally on the tractor or other agricultural equipment they reattach to. That way, they don't need to rely on an internet connection or other cloud services to function properly. This means that once a machine has been trained to recognize certain objects or patterns, it can continue to do so even if it loses connectivity with its cloud-based systems. The computer vision systems used in autonomous vehicles, including cars, tractors, and other agricultural equipment often rely on neural networks known as convolutional neural networks. At their simplicity, CNNs are basically a series of mathematical operations applied to images that allow computers to learn to recognize patterns in pictures. To build a CNN, engineers first upload a massive number of images to a data. Human labelers then manually identify the objects or patterns in each image, creating sets of image label pairs. These labeled images are then used to train a CNN to detect the target objects using only the image and a computer's onboard hardware. So when I say that a CNN can be trained to detect faces, for example, what I really mean is that the neural network has been shown lots of pictures of faces along with the instruction that these are faces. So the next time it sees a picture of a face, it's able to identify it without any further input. This same basic process is being used by companies like John Deere and Carbon Robotics to teach machines to identify weeds. For example, John Deere's See and Spray weed detection system uses CNNs to identify and remove weeds. At CES 2025, the company showed off its new second-generation autonomy kit, which can partially or fully automate common tasks like tillage and weed removal. The company says that in 2024 alone, its See and Spray system was used to spray over 1 million acres of farmland, because the machine only sprays plants identified as weeds. The system was able to do this using 8 million gallons less herbicide than would typically be needed. Sarah Schinkel, the company's director of emerging technologies, says that AI has already improved its agricultural equipment. If you think about that savings, as well as just overall productivity and sustainability improvements for them, that's just a win for them all around, Schinkel said. What's more, it gives farmers more staffing flexibility. Semi-autonomous harvesting equipment, for example, gives the human operator AI assistance that can adjust the equipment more quickly than a typical operator can react. You can put somebody who maybe isn't an expert combine operator in a cab and help them still achieve high performance, said Schinkel. As AI continues to improve, it's clear that these systems will become even more accurate and efficient, potentially transforming agriculture and other industries in the process. Do you think AI-powered equipment could help address labor shortages in agriculture? Let us know in the comments below. And thanks for watching.